Okay, one more quick example here. We're going to talk about some 2D wave interference examples. And this is just putting some numbers to the last couple of videos that I did on what kind of wave interference patterns we would see if two coherent sources is in the same wavelength and same phase, were disturbing a medium and at the same time, so we see the result of those two waves trying to occupy the same space and interfering. So, two sources are vibrating in phase with a wavelength of 0.8 meters. A point on the third nodal line, so nodal in third, so that means n equals 3, and that means we're using this equation, L2 minus L1 is equal to n minus a half lambda nodal, so we get the half third, so that n is going to be 3, from one source. 10 centimeters from one source. So L equals 10 centimeters. How far is it from the second source? So 3 minus a half times our lambda of 0.8 centimeters. So 2.5 times 8 is 20. So 2.0 centimeters. And that is the difference from L2 minus L1. Keep in mind the absolute value there. So the difference in the length of from one source to the other source is 2 centimeters. Now we need to be a little bit careful here because we said it's 10 centimeters from one source and we need the difference to be 2 centimeters. So there are actually two possibilities here. If this 10 centimeters was L1, then we could say L2 minus 10 equals 2 centimeters. And say L2 is 12 centimeters. That's one way to get 2 centimeters away from 10 centimeters. Or if we said L2 is equal to 10 centimeters, then we could have said 10 minus L1 is equal to 2 centimeters. And so L1 would have been negative 8 centimeters, and actual L1 is 8 centimeters. That's a lot of math for saying I have 10 and I need to be 2 away, so I could go up or down, so 12 or 8 are my two possibilities. You don't have to do all this math. If you can use the common sense, you can do that as well. So it's either 12 centimeters from the other source or 8 centimeters from the other source. Let's keep that quick and go ahead and do another one. Two objects are generating waves in phase. A point that is on the third antinodal line is 10 centimeters from one source and 12.4 centimeters from the other source. Determine the wavelength. So first of all, antinodal, which means I'm using this formula. Third, so that means n equals 3. So 3 minus 1 lambda is just equal to 2 lambda. And then 12.4 from one and 10 from the other. So I'll make L2 12.4 and L1 10, and that way I naturally get my positive number. Those are both in centimeters. So my wavelength then must just be 1.2 centimeters. So conceptually understanding the interference pattern and why it's L minus 1 to get constructive or antinodal and minus 1/2 to get destructive or nodal is a little tricky, but the math that comes along with this is pretty straightforward. So there's a couple examples of 2D wave interference math examples.